Hello and welcome to this video. So let's move to the double integration, right? So again we have this let's say this axis. Okay, and we have one smooth surface, right? Now uh, double integration here measure the surface area of this curve. Okay, so we will have to calculate the formula for that, right? So to do that, just like we take this so here we have variable x, so here we take this point xi and xi plus delta xi. So two lines we have drawn which intersect at this curve f equal fx. In the similar way we will take two planes. Okay, so the two planes are going to be, let me first write, this is x, y, and this is z, right? So the two planes will look like this. Okay, so this is the first plane, which is the yi. Another plane, this is the yi plus delta yi. Similarly, we can take two planes for the other variable, which is this x. This is xi, and again another variable, which is this xi plus delta xi, right? So these two planes will give this let's see these and these part of the curve. Okay, this part of the curve will extract out by these four planes. Okay, so this is our plane. And one thing that we know, that the x-axis, first let's say y-axis. Okay, so these are the delta y, this distance is delta y, so obviously this distance is going to be delta yi, and corresponding to that this distance is going to be delta z. This is the z axis. Okay, right? I'm drawing it again, okay, to show the delta x, right? So these and this line, right? So in the similar way, this distance is going to be delta xi, and this is, and let's say this is delta zi, and this is delta zi, right? Now what will the surface area of this plane? So the surface area is going to be, let me redraw this plane. The surface area is going to be this length times this length. And what is this length? This length is actually this one. This particular length is actually that particular length. So we have, what are those lengths? From the Pythagoras theorem we can calculate that this is going to be d yi square plus d zi square and root under, and this length is dxi square plus d zi square, right? We can also write like this, take the delta x common, so we're left with this delta zi by delta xi and delta xi. In the similar way we will common out this delta yi, So we will have this equation. Right. Right. So what will the area? The area is delta A. So what will the area of all the, let's say, all the surface, right? All this green surface. And let's imagine that this green surface, yes, green surface began at some point along x-axis and at some point along x-axis, and similarly for the y-axis, right? So we can specify that point, but let's not do that, because it will because there are already so many x, y, a, and all these terms are there. It may trigger confusion. So let's not do that. So the total area of surface is the summation of this individual areas. Okay, this is delta ai, right? I equal to, let's say, 1 to n. Okay, right. Now what we do again, we have two variable x and y, so we will just take this delta, all the delta xi is just delta x, and all the delta yi is delta y. So we are just distributing this 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 planes into a equal distance. Okay, so all the equal distance along the x-axis is this delta x, and for the y is delta y, and we are taking the limit delta x comma delta y tends to 0, but we will left with the integration sign and this dA. Okay, so we will just limit out this and produce this. Okay, what is this dA? dA is nothing but, here comes our topic, which is the double integration. So we have these two variables instead of one, which is the x and y, so we will take the double differentiation. This is the meaning of double differentiation, double integration, I'm sorry, the double integration, right? So it is going to be dA, and dA is what? The product of these two, or these two numbers. So let's multiply these two. The first term is 1 plus, okay, by the way, if we just apply the limit delta x comma delta y tends to 0 in these and these, it will produce the partial derivative. Okay, 1 plus del f by del x whole square 1 by 2, and 1 plus del f by del y whole square 1 by 2 with dx and dy, and obviously we can just add the limit for x and y in over here. Okay, so this is the area we can calculate of any surface if we know the know the equation of that surface, right? In the similar manner, we can calculate the volume, right? We can extend this formula for three-dimensional case, right? And for that case, we're gonna have this triple integration, right? For the x, y, and z. So we're gonna have this one, some function, let's say del f by del x whole square, right? And f is the function of x, y, and z. 1 by 2, 1 plus del f by del y whole square 1 by 2, 1 plus del f by del z whole square 1 by 2, and dx, dy, and dz. And we can always put the upper and lower limit of all these three variables, right? We can also extend this formula for the n-dimensional space, right? The volume of n-dimensional, let's say n volume, for n equal to 1 it is going to be length, for 2 it is going to be surface, for 3 it is going to be volume, right? It may look like something like this, right? So let's say there is a